Greetings of the day. I am Mohini Rasar, working as an assistant professor at All India Sri Shivaji Memorial Society's College of Hotel Management and Catering Technology, Pune. I will be introducing you to this session of Physics under the Bridge course. The topic for this session is on thermal expansion and specific heat capacity, part 2. Now, let's take a look at the objectives of the session. Students will be able to understand and grasp the concept of specific heat capacity and its significance in heat transfer process. You will also be able to learn about specific heat capacity and how it is calculated using the formula. Further, you will explore the connection between specific heat capacity and thermal expansion, understanding how heat energy affects the expansion or contraction of materials. You will also be able to recognize the importance of specific heat capacity in everyday scenario such as cooking, climatic regulation and material selection for insulation. You will also be able to understand better how specific heat capacity is used in hospitality. Now, welcome to our session on specific heat capacity, where we uncover the sources of how substances store and release heat energy. Let us dwell into the fascinating world of heat. So, what exactly is specific heat capacity? Imagine it is a superhero's cape that substances wear to resist the change to the temperature. It tells us how much energy a substance can hold per unit mass. So, specific heat capacity is defined as the amount of heat energy required to raise the temperature of a unit mass of a substance by 1 degree Celsius or by 1 Kelvin. It is denoted by C. The formula for specific heat capacity involves Q, which is the heat energy absorbed or released, M, which is the mass of the substance, and delta T, which is the change in the temperature. In terms of unit, specific heat capacity is typically measured in joules per kilogram per degree Celsius or in joules per gram per degree Celsius. Looking at or talking about significance of specific heat capacity, it varies among different substances and is a measure of how effectively a substance can store heat energy. Substances with high specific heat capacity require more energy to raise their temperatures in comparison to those with lower specific heat capacities. Talking about applications of specific heat capacity, the first one is thermal insulation. Materials with high specific heat capacities such as water and certain types of rocks are used in thermal insulation to regulate the temperature changes. In terms of cooking, understanding the specific heat capacity of different ingredients helps us in controlling cooking temperatures and making sure it is even cooking. In terms of climate regulation, bodies of water with their high specific heat capacity play a crucial role in moderating climate by absorbing and releasing heat energy slowly. Now, let's break down the formula for specific heat capacity. It is, as mentioned before, calculated using C equals to Q m dot delta T, where C is specific heat capacity, Q is the heat energy absorbed or released, m is the mass of the substance, and delta T is the change in the temperature. But how does specific heat capacity relate to thermal expansion? Let's take a look at this relationship between specific heat capacity and thermal expansion. When you heat up a metal rod, you are essentially transferring energy to the atoms within the material. This added energy causes the atoms to vibrate more vigorously, increasing their kinetic energy. As a result, the average spacing between these atoms increases, which leads to the expansion of the material. Now, let's bring specific heat capacity into picture. Specific heat capacity is a measure of how much heat energy a substance can absorb per unit mass to produce given temperature change. It essentially tells us how resistant a substance is to changes in temperature. And in the case of the metal rod, the specific heat capacity influences how much heat energy it can absorb before its temperature starts to rise significantly. If the metal has a high specific heat capacity, it can absorb a larger amount of heat energy without undergoing a significant temperature change. This means that even though the metal rod is absorbing heat energy, the temperature may not rise rapidly. However, despite its resistance to temperature change, the metal still undergoes thermal expansion due to the increase in kinetic energy of its atoms. This expansion occurs because the atoms are vibrating more vigorously, pushing against each other and causing the material to expand in all directions. So while specific heat capacity primarily affects how much heat energy is required to change the temperature of the substance, it indirectly influences thermal expansion by determining how much heat energy a material can absorb before experiencing a significant temperature change and subsequently expansion. In summary, specific heat capacity and thermal expansion are interconnected aspects of materials' behavior in response to heat energy. Now, where specific heat capacity comes into play, substances with high specific heat capacities like water can absorb a lot of heat energy without their temperature changing much. This means they resist thermal expansion to some extent. Now, let's see why specific heat capacity matters in our daily lives. Think about cooking your favorite dish. Different ingredients have different specific heat capacities, affecting how quickly they heat up or cool down. Specific heat capacity also plays a vital role in climate regulation. Different bodies of water with their high specific heat capacities absorb and release heat energy slowly, helping to moderate temperature changes in our environment. And when it comes to choosing insulation material for our homes, we look for substances with low thermal conductivity and high specific heat capacity. These materials help keep our homes warm in winter and cool in summer. Further, so whether you're cooking up the storm or enjoying a swim in the ocean or staying cozy in your home, remember the unsung hero, specific heat capacity, is working hard behind the scenes to keep these things just right. Now, let's take a look at how specific heat capacity plays a significant role in hospitality industry, particularly in food preparations. So, talking about food preparation, specific heat capacity influences cooking process in commercial kitchens and restaurants. Different ingredients have varying specific heat capacities, affecting how they absorb and release heat during cooking. Chefs need to understand these properties to ensure precise cooking temperatures and consistent food quality. For example, meats. Meats like pork, beef, chicken, lamb, and few others have relatively high specific heat capacity in comparison to other food items. Understand, this allows chefs to adjust their cooking time and temperatures to ensure thorough cooking without overcooking or drying out the meat. Next, vegetables. Vegetables often have lower specific heat capacities in comparison to meat. Chefs used to account for this difference when incorporating vegetables into dishes to ensure there is no overcooking, but there is even cooking and optimal texture. Specific heat capacity is not only the part of food, but it is equally important for beverage service. So specific heat capacity also influences beverage services in the hospitality industry, particularly in the preparation and serving of a hot or cold beverage. For example, coffee and tea. Specific heat capacities affects the brewing process of coffee and tea. Understanding the specific heat capacity of water and various teas or coffee blends helps barista achieve the desired flavor extraction and temperature control during brewing. In terms of cold beverages, when serving cold or iced beverages such as cocktails or chilled juices, the specific heat capacity of ice is crucial. Bartenders must consider the amount of ice needed to achieve the desired temperature without diluting the drink excessively. In terms of climate control, in hotels, restaurants, and other various hospitality venues, specific heat capacity influences climate control systems and energy efficiency. The considerations include HVAC systems. Specific heat capacity affects the thermal properties of building material and insulation. Hospitality industries or establishment use this knowledge to select appropriate insulation materials that can effectively regulate indoor temperatures and reduce energy consumption. In terms of temperature management, understanding specific heat capacity helps hospitality managers to optimize HVAC systems or settings for the guest comfort while minimizing energy cost. For example, leveraging the thermal mass of a building material with high specific heat capacity can help stabilize indoor temperatures and reduce the need for constant heating or cooling. Overall, specific heat capacity plays a crucial role in the hospitality industry by informing food preparation techniques, beverage service standards, and climate control strategies. Hospitality professionals who grasp these principles of specific heat capacity can enhance operational efficiency, improve guest experience, and contribute to a sustainable practice within the industry. Before we conclude the session, let's take a recap and understand. Specific heat capacity is the amount of heat energy required to raise the temperature of a unit mass of a substance by 1 degree Celsius or by 1 degree Kelvin. It varies among different substances and influences how effectively a substance can store heat energy. In terms of the revision with the formula, specific heat capacity is calculated C equal to Q m dot delta T, where Q is heat energy absorbed or released, m is the mass of the substance, and delta T is the change in the temperature. In terms of relation to thermal expansion, specific heat capacity indirectly affects thermal expansion by determining how much heat energy a material can absorb before experiencing a significant temperature change and subsequent expansion. Substances with high specific heat capacity resist thermal expansion to some extent. Specific heat capacity practical applications in the scenarios are: in cooking, it influences how quickly ingredients heat up or cool. In climate regulation, specific heat capacity of the substances like water help moderating the temperature changes. In insulation material, specific heat capacity contributes to effective temperature regulating in homes or wherever you apply. The significance is understanding specific heat capacity helps in controlling heat transfer process, selecting suitable material for various applications, and optimizing energy efficiency in everyday life. Till then, stay curious, stay warm, and keep going exploring the wonders of heat. Thank you so much.